Okay, so for homework 6, on the first problem, we have a program that finds the greatest common divisor, and fairly short one out of the set of homework. We have our main program, 2 integers, because we're trying to find the greatest common divider between the two. So prompt for entering an integer, and then we need to enter a smaller integer. That just saved some trouble, made the program shorter, less complicated. We read both of those inputs, and the greatest common divisor is, and then we find out what that is from our function, or recursive function up here. So we pass the user inputted parameters. If this is where the second one being smaller comes into play. So if the bigger one divided by the smaller one gives us a remainder of 0, we know that that is the biggest common divisor, so we return that integer. Else, the greatest common divisor is a recursive function. We pass the second variable as the first, and then we pass our first variable mod the second. And so that will keep searching until it finds one that satisfies this 1 modulo 2 equals 0 remainder. And once it finds that as it's working its way down, then we know that that is the greatest common divisor. Our second problem, also somewhat simple, was an integer displayed in reverse, but it had to be done recursively. So we get a number and we pass that to our reverse display function. If the value is greater than 0, because if it's 0, you can't really reverse that, then we will see out the value mod 10. So when you divide it by 10 and take the remainder, we will get the last number. And then to get rid of that number so it's not used anymore, we call this function again, but instead of passing the original value, we pass the value divided by 10. And so that will take off the number we just used. And it will keep doing that and outputting from right to left until the number is finished. Because when the number is finished, the value will not be greater than 0. And we will return down here, exit program. All right, for homework 3, definitely jump to a lot more complicated. So we have our main driver. I have an integer. Please input a positive integer. And then we need to find its hexadecimal equivalent in a string. So you could actually just type in, there's a way to type in to read a decimal as a hex number very simply, but this definitely made it a lot more challenging. So what I did was create a character array that would be plenty big for most any number. If the value is not equal to 0, then we will have a temporary value that is our number mod 16. So with hexadecimal numbers, we divide by 16, take the remainder, and you work from there. It's the way to convert. And so to change that number into an ASCII character, because hexadecimal has A through F as well as 1 through 9, or 0 through 9. So if it is less than 10, then we add 48 to that. It should give us the appropriate ASCII. And then else we add 55 to give us the appropriate ASCII text. And then after we've found that, we want to get a new value. So we divide by 16 rather than the mod, because we don't care about the remainder anymore. And we'll pass this new value back recursively to our string function, and it will do the same thing until it is finished. And because I used an character array and it's returning a string, I created this string hex, and then since we parse through this if we outputted it directly, it would be backwards, so it would not be correct. So we have to start at the end of the array that has values and work our way down. And then to add those ASCII characters to a string, uh, it actually is an add function. So hex plus equals each character as it goes along, and it will read that as its appropriate ASCII text. I think for my example, I put in like 10, which will output A, or 11 should be B, 12 C. And so then it returns our string. Then for the final program was the in Queens pro. We have our in Queens program. In this particular example, it was an 8x8. Didn't really give a lot of specifics. Just a program that will solve the queen program. It's basically like a Sudoku puzzle. There can only be one of the queen. In this case, I just use zeros and ones. There can only be one in each row, column, diagonal. And so, very simple main program because the rest are recursive functions. So we start with the check solution and we create our board of a certain amount of numbers. I just used a global constant integer, so that way it was very simple to keep everything the same. If you wanted to change the size of the board, it would be very simple as well. So we check our solution, and then we will work through this board and find out if there is an option available. If so, we'll go do solve queen. We have our pool, so it will provide our stars 0 or 1, and it will work through the columns as well as it will work through the columns through the board and find out whether this can be solved. It will put in, we see here return true or return true or return false, so that will decide whether that 0 changes to a 1 or not, determining that we have a queen. And then within that function, it also comes to this function for is valid. And so we are checking our rows, our columns, we're checking our diagonals. So if any of these come back incorrect, then it will be false. So it will tell us that that option is not available, and it will tell us, it will come up with something else. And then this solve queen is recursive, so it calls itself as it's working through the columns. And then finally, it will print the board. In this case, it prints the same one each time generally, but it will print out an 8x8 with ones and zeros in the correct positions. And that does it for this homework.